Hello everyone. At this time I'll introduce the theorem called as complete factorization theorem and its proof. This theorem requires three lemmas. At first, lemma 1 is as shown like this. Let's keep in mind the result of this lemma. Px is equivalent to x minus alpha time of qx plus p alpha. And go to the next lemma. Lemma 2 is like this. Lemma 2 is called as factor theorem. When p alpha is 0, then px can be factored as x minus alpha time of qx. And go to the next lemma, lemma 3. Lemma 3 is like this. Lemma 3 called as fundamental theorem of algebra. Fundamental theorem of algebra's proof is very difficult. I will not introduce the process of this proof of this theorem because the proof of this theorem requires the knowledge with the level of undergraduate course in math. Just all the time keep in your mind this statement. I will use this theorem to show or prove other theorems. Let's read. Px, every px with complex coefficients has at least one complex zero. Then let's prove the theorem, complete factorization theorem. First application of fundamental theorem of algebra is this theorem called as fundamental theorem of algebra. Let's see, every polynomial px with complex coefficient all the time has at least one complex zero. Oh, mistake. Let's see, this theorem is a complete factorization theorem. If px, let px be a polynomial of degree n is larger than or equals to 1, then there always exist complex numbers a, c1, c2, and so on, cn, such that px is equivalent to a times of x minus c1 times of x minus c2 and so on times of x minus cn. This is the result of this theorem, and let's prove. Let's prove this theorem. Px can be factored as x minus c1 q1x, where q1x with degree n minus 1. By lemma 2. Can you remember the lemma 2? To repeat this theorem, you can see page on the textbook page 272. And Q1x can be factored as x minus c to Q2x, where Q2x with degree n minus 2. Also by lemma 2. To repeat this theorem, you can see also page 272. Continuing these processes for n steps, we get a final quotient Qnx of degree 0. Then go ahead, x minus c1 q1x, and also x minus c1 by lemma 2, q1x also can be factored as x minus c2 q2x, and by lemma 2, q2 also can be factored as x minus c3 times another polynomial. And repeat these processes. Finally, this polynomial px finally can be factored as x minus c1, x minus c2, and so on, x minus cn and q n x by lemma 2, and qnx where qnx with degree 0. Degree 0 means constant. Then px can be factored as finally x minus c1, x minus c2, and so on, x minus cn times degree 0 polynomial constant a. This is the end of proof. Let's see the example 1. Example 1. Px is equivalent to x cubic minus 3x squared plus x minus 3. To factorize this polynomial, at first we can find the all solutions of this polynomial. Px can be written as x squared x minus 3 plus 1 times of x minus 3. And the common factor is x minus 3. Then x minus 3 times of x squared plus 1 by distributive property. And if this polynomial is equivalent to 0, then x minus 3 is 0 or x squared plus 1 is 0. Then solution of this polynomial is 3, or x squared plus 1 0 is plus minus I. Then all solutions of this polynomial or all zeros of this polynomial p is 3 or I or negative 1 times of I. Then by this theorem called as complete factorization theorem, px can be factored as x minus 3 times of x minus I times of x minus I means x plus I. Let's see the next example, example 2. Px, given polynomial Px is equivalent to x cubic minus 2x plus 4. And by synthetic division, 1, 0, negative 2, 4. Then candidate of the 0 is negative 2. Then 1, negative 2 times of 1 is negative 2, and the sum of 0 and the negative 2 is negative 2. Negative 2 times of negative 2 is positive 4, and the sum of them is 2. And the negative 4, and the final 0. Then by this process, Px can be factored as x plus 2 times of x square, negative 2x plus 2. Then, if this polynomial equivalent to 0, then x plus 2 is 0 or x squared minus 2x plus 2 is 0. Then first 0 of this polynomial is a negative 2, or we can find the all solutions of this polynomial by quadratic formula. X is 2 times of leading entry, and negative 2 is positive 2 plus minus square root square of linear coefficient 4 minus 4 times 1 times 2. Then all solutions of this polynomial are negative 2 or 2 plus minus square root 4 minus 8 is negative 4. Square root of negative 4 means imaginary number. Then x is negative 2 or 2 over 2 means unit number, and plus minus 2i. 2i over 2 is I. Then all of these polynomials are negative 2 or 1 plus I or 1 minus I. Then by this theorem called as complete factorization theorem, this polynomial can be factored as x minus 2, x plus 2 times of x minus 1 minus I times of x minus 1 plus I. This is the factorization of this polynomial.